Okay, so we're still talking exponential functions. Y equals a times b raised to the x power is kind of the general form of any exponential function. We briefly talked about yesterday how the a value is our starting amount, or also you could think of it as your y-intercept. The ones we did in class yesterday, what was the y-intercept on every single one of them? 1. 0, 1. Yep, the y-intercept was always 1. That's because you really didn't see an a value in your equation. You just saw y equals 2 to the x power. So you just saw b to the x. You didn't see an a value there. Well, if you want to put a 1 there, you certainly could. It's like y equals 1 times 2 raised to the x power. All right, so if you don't see an a value, it just means your y-intercept is 1. Okay? So that's kind of the ones we did yesterday. B is your growth or decay factor. How do you know when it's growth? The b values are bigger than 1. Can you explain to me why that would make them grow if the b value is larger than 1?
Because it's 2
It's to a power, and so that means you're doing what with that b value?
Making it bigger.
You're multiplying it by itself, right? If you multiply something by a value that is larger than 1, what is going to happen to that value?
It'll get bigger.
It's going to grow. It's going to get bigger. Even if you multiply by 1.01, it gets bigger, right? What happens if you multiply something by 0.99? It gets smaller, right? So any number between 0 and 1 is going to make it get smaller. Obviously, the closer it is to 0, the smaller it gets faster. The closer it is to 1, it'll get smaller just slowly. Okay? So, is that logical? Makes some sense? Okay. So, with that, if I would ask you to put the thing in the computer so I can actually use this, that would help. So write down this equation. Y equals 3 times 2 to the x. Y equals 3 times 2 to the x. How can you tell that's an exponential function? It's got an x where?
The power spot?
Yeah, in the exponent, right? You should be able to graph this without too much difficulty, without a calculator. Okay? Where will this one cross the y-axis?
3.
At 3, at your a value. As we move to the right, is this graph going to grow or decay? Grow, because our b value is bigger than 1. In fact, how fast is it going to grow as we move one unit over to the right over and over again?
Pretty fast.
It's going to, by a factor of 2, it's going to double, right? So your coordinates would be we said the y-intercept is 3, so when x is 1, y would be 6, right?
Yeah.
It's going to double. Coming back, when x is negative 1, what would it be? Well, if 0 is at 3, then at negative 1 would be at 1.5, half of it, right? If as we move right, it's doubling. As we move left, it's halving, right? So at negative 1 would be at 1.5, at negative 2 would be at 0.75, and so on. And then this would be a rough sketch of that graph. Horizontal asymptote at y equals 0. Questions on that? If I give you one like that, do you feel like you could draw a quick sketch of it without having to do a whole lot of math?
Yeah.
Okay? What would happen if I would put a minus 4 back here?
It would go
Down
down
4.
Everything would just drop 4 units. Okay? You guys have worked with transformations before. So I'm just telling you, you might have some that you have to move up or down after you apply the a times b to the x part. Okay? I'm not going to go through one of those, but all I would do is just take every one of these coordinates and move it 4 units down. Move it 4 units down, and so on. Where would my new horizontal asymptote be? Y equals -4.
Horizontal last. Yep.
Right? Because here I have a horizontal asymptote at y equals 0, but if I got to shift everything down 4 units, now my new horizontal asymptote would be at y equals -4.
And
Okay?
our y-intercept would be at -1.
Our y-intercept would then be at -1, yes. Yes. Okay? How we doing?
Great. Good. No, we're not good, but great.
Okay? Alright?
Stop, we're great.
Okay. Let's see, what else do I want to do with this? I think you could, I'll just do one more quick little practice. Why don't you guys graph this? And I'll even put in this for you. Y equals 2 times 1/2 raised to the x power plus 1. Exponential growth or exponential decay?
Okay.
Decay, how can you tell?
Less than 1.
The b value is less than 1, between 0 and 1.
That's half 1/2, 1/4. There's a quick sketch of the final graph. It has a horizontal asymptote at y equals 1. It now passes through the y-axis at 0, 3. It would have started at 2. Your original starting amount, or your original y-intercept would have been 2, but then the plus 1 moves everything up 1, so now my new y-intercept is at 3. Okay? And as we move to the right, okay, your values would be cutting themselves in half. Okay? So again, if you started it at 2, then it would have been at 1, then it would have been a half, and a fourth, and an eighth, and so on. And then we shift all those values up, and you would end up getting 1, 2 as a coordinate, -1, 5 as a coordinate. Yes? No? Questions? Good? Good? You guys? Girls? Yeah.
Okay. Alright. So graphing, okay? What if throw a negative exponent up there?
Flip it?
What do you think?
Would it flip it over the...
Explain. So tell me what to write, baby. You're right.
So flip over the x-axis or y-axis?
Okay, it would reflect it. I like that. You're saying this graph would look like this one, just reflected over the y-axis, because you remember from transformations, when you replace an x with a negative x, that reflects it over the y-axis. I like that thought. Good. Okay. So this graph
would look like this one reflected over the y-axis. Okay? If we reflect this one over the y-axis, well, this graph here is growth, right?
Yeah.
If I reflect it over the y-axis, then what's this one going to be?
Decay.
Decay. Okay? Let's algebraically show why it's decay. What would this equal? Use your exponent rules.
1/4.
1/4.
Mm-hmm. Because a negative power would move that to the bottom, right? So you get 1/4 to the x. And isn't that really the same thing as 1/4 to the x power, like that?
Yeah.
Because 1 to the x power is always going to be 1, and 4 to the x power is what we had in our denominator anyway. So 4 to the negative x is really the same thing as 1/4 to the positive x. Now is it easy to tell that that's going to be decay?
Yeah.
Because our b value now is between 0 and 1? You guys alright with that? Okay. So, the next thing I'm going to have you do is I'm going to have you work through the second sheet of that exploration I gave you yesterday. It will have negative x as the exponent. If you kind of use this idea and the algebra behind it, you should be able to sketch those graphs pretty quick here. We'll talk about them just a little bit when you're done. Okay? And then we'll do a little bit of practice on the graph. I'm going to pause the video.